honored guests, respected colleagues, and dear friends. Good morning, everyone. Today, we embark on an exciting adventure, a journey that opens up the gates to our future, making path to the opportunities in natural language processing and machine learning. As we gathered here, let's reflect on the insightful word of Steve Jobs, who said, "The only way to do great works is to love what you do." These words perfectly capture the spirit of our mission at SA Engineering College. With passion and determination, let's set forth to explore new horizons and unlock the potential with us all. SA Engineering College was established in the year 1998 by the visionary Dharma Naidu Educational and Charitable Trust. Our institute stands as a testament to the unwavering commitments towards shaping the future through education. Guided by the noble ideals of imparting knowledge and nourishing talents, we have carved a niche for ourselves in the realm of technical education. At SA Engineering College, excellence is not just a goal; it is a way of life. With the relentless pursuit of academic brilliance, we offer a diverse array of 11 undergraduation and 4 post-graduation courses with a Master of Computer Application and Master of Business Administration. We strive to provide our students with the tools they need to live in an ever-changing world, and our campus. It's more than just a brick and mortar. It's a vibrant ecosystem designed to foster creativity, innovation, and collaboration. From our state of art labs to our spacious classroom, every aspect of our campus is geared towards empowering our students to reach their full potential. But none of this would be possible without the dedication and expertise of our estimate faculty members who serves as a mentors, guides, and role models to our students. Today, as we have come together for this special tech series 4.23 on the role of ML in data modeling and visualization, we honor to have Mr. Sanju Sri Vashini, who has 3 years of experience in most trending topic ML and has done many projects based on ML, machine learning such as tokenization, named entity recognition, sentiment analysis, and some other projects like NLTK, BERT, and so on. She is a person of good leadership, constant creativity, and a girl with very good communication. We are honored to have you as a speaker for today, ma'am. So let us give welcome Mr. Sanju C. Vashini to take the meet. Ma'am, you can take the meet.
Yeah, thank you so much, Kavya. I'll share my screen. Hello everyone, I am Sanjushri Vashini. I hold a BTech in Artificial Intelligence and Data Science with experience in developing machine learning models and deployment tailored to unique business needs. I have also published research papers in reputable AI journals, which include the work on large language models as well. I create content on YouTube on the channel named AI with Sanju, where I uh, upload tutorials related to artificial intelligence. I am super excited to walk through the session on the role of machine learning in data modeling and visualization. Without any further ado, let's get started. First, I want to engage with you all. So please post your answer in the chat box to this question. What do you think machine learning is? Whether it's a type of computer programming or a system that can learn from data or robots taking over the world. That is the talk every time and everywhere, right? And if you're not sure what machine learning is, just post not sure. I'll just wait for a few seconds. Just type whatever you think machine learning is. Okay, option A. I'll just wait for a few more seconds. Okay, another person says option A as well, a type of computer programming. And Manisha says it's a system that can learn from data. Okay, okay. Moving on with the answer, machine learning is more than a type of computer programming. It is it can understand data and react accordingly, make prediction based on the data. It is essential about building system that can learn from and make decision based on the data. So let's get started. Let's get yeah. Moving to the objective of this session, we will understand the basics of machine learning, learn about data modeling and why it is important, discover how visualization helps to interpret data, and we will explore what are the common types of data visualization that are used. And then we will work on and create a simple machine learning project to kickstart the journey. Okay. Moving on, what is artificial intelligence, machine learning, and data science? To set the stage, let's clarify the difference between. Most of them come up with their unique definitions and ideas, and some people say these are different domains. Don't accept that, okay? One of my guide said this definition, and I always stick with this. That is, artificial intelligence is the just think about an intelligent system which can perform tasks like somewhat like human. It can think and act accordingly with the data given to it. So that is the goal. Artificial intelligence is the intelligent system. That is our goal. And data science is what the roadmap is. It involves collecting, analyzing, interpreting large amounts of data. This is what roadmap of for the artificial intelligence. And then moving on to machine learning, it's like a toolkit. It provides the algorithms and techniques used to create these intelligent system. To come on again, artificial intelligence is the aim. Machine learning is the toolkit that is performed on the data science roadmap. This is what my definition is. Moving on with some common examples. As you all order products on Amazon or watch movies on Netflix, Amazon Prime, and so on, you get, once you purchase a product, you get and other products related to it coming popping up to you, so that it acts in a way it compelling to buy the related products. So recommendation system comes there. Voice assistant like Siri, Alexa, all those are able to understand what we speak and process it and reply with relevant answers. Next, followed by email spam filtering. When you open your Gmail, you are able to see their spam column separately, where the unwanted emails are not so important emails are just pushed onto this spam folder. That is one kind of example. And predictive text. So consider Grammarly, when you type words, it automatically corrects the spelling and grammatical errors. That is autocorrection. And text suggestions, when it comes to consider you are searching for something on the Google. When you type what is, it automatically gives you a lot of suggestions based on your previous history or people around your locality. That is text suggestions. So these are some common examples that we use in our day-to-day life. Moving on with types of ML. Okay. Machine learning can be categorized into three types: supervised, unsupervised, and reinforcement. Supervised is where the model is trained on the labeled data. For example, predicting house price based on some historical data that is being collected. And supervised learning, we will look deeper. Just keep these keywords alone in your mind. Supervised for label data set. That is, you know what is input and what is output. And unsupervised is for you don't know what's your output, you just have the data and you're trying to figure out what are the patterns present in that data. Example like uh, clustering customers based on their purchase in a supermarket or something like that. Okay, moving on to reinforcement learning, this is where the model is interacting with an environment and receiving rewards or penalties. Consider you're training a AI to navigate on a maze. So each and every time you won't be giving a different maze, right? You will be giving a different types of maze. So it has to act accordingly, which is the optimal path. It has to think and act accordingly. These are some, and self-driving cars are also an example. Moving on with the next one, we'll just look into some basic examples and how it works. Okay, moving on to supervised learning. As I mentioned, labeled data for supervised machine learning. You can see there's an apple picture and it's labeled as apple. There's a strawberry picture and it's labeled as strawberry. We know what is the input is going to look like and what is the output for that particular input. This is what it is. Okay. Then we give the data and train them so that our output will be or strawberry or apple or any other fruit that you trained on. This is going to be this. We know what is the input and we know what is the output. We train and we predict. This is what supervised learning is. And moving on to the example, like I mentioned, image classification, like fruits, animals, or any other objects, it can be. Okay. And spam detection, as I already mentioned, email spam. Just try, just keep in your mind like you are having a large amount of emails labeled as this is not a spam, and this, when the email looks like this is definitely going to be a spam email. So you label the data, you train the machine learning model, and that model is implemented on your Gmail, so it automatically filters whether it's a spam or not a spam. That is how it basically works. Moving on to unsupervised learning. Okay, I would give an example of, consider a customer data on a supermarket. Okay, there are customers who buy expensive products often, and there are customers who don't purchase expensive products often. So these are the data, these are the customer data, and with the purchase history, we are going to categorize them into three groups: A, B, and C customers. Who this group is like, they purchase expensive products often. They are like not so much expensive, a little lesser than that. And they are C is the customer who don't purchase expensive products at all. So once you've done this, you may ask, what is the use of this finding of, for supermarket, what is the use of finding their their customers A, B, and C? So for instance, they are launching a new product. Okay, there are different supermarkets available. Now this particular supermarket, consider, has a large number of customers who purchase expensive product. Then an expensive product which is new should be launched in this market, so that the reach will be high. People, there is a high possibility that the customers will purchase the expensive product, right? So these are some common example. This is called clustering. You are grouping the data, similar data. Okay, and moving on to anomaly detection. Anomaly detection is like, consider there is a basket which contains apples. Okay, apples varying with some slight different in their color, in their shape, in their size, in their weight. Okay, and then there's a watermelon present on the same basket. Then when you take the data records, like considering the color, weight, and all those, you will have the watermelon size and data alone to be like varied so much. Because considering an apple, watermelon is huge, right? So that is an unusual data point in the data. So figuring out and understanding, detecting those anomalies and reducing those anomalies will help us to get better results. Okay, moving on to reinforcement learning. This is like training a model to make decisions by rewarding desired behaviors and punishing the undesired ones. It's like more like teaching a dog new tricks with treats. The model learns the best actions to take in different situations by maximizing cumulative rewards. Okay, it's like consider you're playing a game, playing chess with your computer. Okay, when you play chess, not every time the computer gives keeps on giving the same moves. It changes its moves based on the opponent's moves. So it is like getting trained how to play efficiently. It is led into a new environment like uh, playing chess or playing a video game. Consider here, AI agents are trained to play video games, learning to navigate and make decisions in real time environment. And as I already mentioned, self-driving cars, automatic vacuum cleaner, all these are examples of these. Okay, you are letting the AI agent on a particular environment and asking it to learn by itself. Like you will, of course you will set some rules. Like there are rules to set on, like this is how you need to play chess. This is how the knight moves, this is how the king moves, this is how the queen moves. There's the rules, right? You teach that to the agent and let it play on the environment. It learns gradually. This is what reinforcement learning is. This is quite different. Moving on, what is data modeling? Okay, data modeling is the process of creating data representations for machine learning to understand and make prediction. It helps transform raw data to meaningful insights by identifying patterns and relationships. In simple terms, it's like creating a blueprint that shows how data is structured and connected. Okay. Um, Now consider you are having a problem. So what you need to do to solve that problem, you can use AI. If you can use AI, you need to collect data so that you can solve the problem. So you collect data from various source, you dump it on a data database, and then moving on, you transform the data in that is understandable to make predictions. Okay, transforming the data in an efficient way is called data modeling, and then trying to identifying patterns and relationships. This is what data modeling is. Moving on with steps in data modeling. Okay, data modeling involves the first step of data collection. First up is data collection. This is where we gather all the data needed for our project. Think of it like gathering ingredients before cooking a meal. The more accurate, the comprehensive our data, the better our model will be. Okay, and then think of it like, then next, moving on to data cleaning. Okay, data cleaning is just like washing your vegetables before cooking. We need to clean our data to remove any errors, duplicates, or null values that is present in the data, or some irrelevant information like watermelon present on the apple fruit basket. Okay, clean data is crucial because it ensures our model isn't learning from bad information. So, first is data collection. You collect the relevant data, and data cleaning is like um, cleaning your data so that it does not have any errors, duplicates, or irrelevant information. Then, next is followed by data explanation. This is the fun part. Here, we dive into the data to understand its patterns and relationship. It's like being a detective, uncovering hidden insights and stories within the data. We use visualization and statistical tools to get clear picture of what our data exactly looks like. Okay. Um, it we will actually work on the different common visualization techniques, and we will try it out hands on. Okay, next comes the feature engineering. Feature engineering is where we get creative. We transform our raw data into features that better represent the problem we are trying to solve. It's like taking raw ingredients and preparing them in the way that our final dish is delicious. Okay, these steps can involve creating new variables, modifying the existing one to improve the model's performance. In feature engineering, you are trying to figure out what exactly are the features that you need in order to predict the outcome. Okay, you are trying to get the correct data for the right prediction. And then comes the model selection and training. This is where we choose the best machine learning algorithm for our task and the data in order to train. Think of it as choosing the right recipe and following it to cook our meal. Okay, we use different algorithms and tweak them to find the best one that gives us the highest accuracy. Okay, then moving on to model evaluation. This is the final step. This is where we test our model to see how well it performs on new unseen data, like tasting our meal to make sure it's perfect. We use various metrics like accuracy, precision, recall to evaluate the model's performance. These may sound like buzzwords, but these are like the evaluation metrics. Okay, it is not up to the mark. We If it is not up to the mark, we go back and tweak our recipe, or in this case our model, until we get it right. Okay, and there excuse me, and there you have it. These are the steps in data modeling. It's a journey from raw data to meaningful insights, much like cooking a delicious meal from raw ingredients. Each step is crucial and adds its own flavor to the final outcome. Okay, moving on to the examples. Coming on to examples, predicting. These are some common examples that is used in our day-to-day life. Okay, predicting student grades using features like study hours and attendance. Consider you want to predict student grades. You are using like how much time do they study for a week, and then considering their attendance. Next is like weather forecasting. This is the common, as you can see, it is going to rain tomorrow, it's going to be sunny day after tomorrow. All those are predicted using our historical weather to understand the future conditions. Okay, and next is like predicting house price based on the size, location of the house, and number of rooms and other features that is being present in the house. These are some common examples. Moving on to data visualization. Data visualization is crucial because it helps us to understand what our data is. When so, just consider you are having a data in an Excel format. One, it's a large amount of data, right? You won't be able to understand once you see them, but once you visualize them and try to understand the patterns present in that data, then you will have some clear idea what the data is and how to work on it. All those will help us to understand the data in a better manner. It facilitates facilitates communication of insights through storytelling. Data visualization is an absolutely game changer for storytelling. It enables us data driven decision making, okay? Moving on to the common types of visualization that is being used, we will work on generating these graphs, but just in simpler terms we'll just look on what is these graphs are. Okay, bar chart, this represents the categorical data with the rectangular bars. Okay, what is categorical data? Categorical data is nothing but when you're able to put your data into categories, or when you're able to group the data. For example, um, consider you're having your t-shirt size, okay? XS, S, M, L, XL, it goes on, right? You are able to put into a category of, you are able to categorize the t-shirts into various groups. That is what categorical data is. When you're able to group the data, you're able to it is called the categorical data. This can be represented in bar chart. This is a great way to represent categorical data. Moving on to line graph. This shows the trends over time with the line. Okay, when you have your data changing over time, you can use this line graph to represent how it, in order to know how it actually changes. Histogram, then comes the histogram. This displays the distribution of the data. So consider you are having student marks and then their class. So consider ninth grade students have 90 marks on 10 people have scored 90 marks. Then the frequency will be present here, and what are the marks will be, what 90, 80, the marks will be present in the X column. The distribution of the data will be like clear in histogram. Okay, moving on to scatter plot. Scatter plot is nothing but, consider you're having two variables to show their relationship. You can plot x and y, two different variables, in order to understand what is the relationship between them, whether it is, are they similar, or do they increase when other increases. All those can be understood by scatter plot. Then moving on to heat map. Heat map represents the data values with colors. So consider you can actually find correlation using heat map. Correlation is nothing but, um, trying to figure out how well your data is able to understand, um, how well your data is able to correlate with each other. For example, there are two features. Um, one is student marks, and other is student study time. Okay, when the student study time increases, the marks also gradually increases. Then this is called positive correlation. As one variable increases, the other also increases. All these relationship can be figured out using heat maps. Moving on, we will look on the demo. We will use the iris data set, which includes the measurement of iris flowers, and then we will try to visualize and create a simple model, okay? I hope you are able to see my Jupyter Lab screen. Are you able to see the screen? Yeah, yep, it's good. Okay. First step is, we import the necessary libraries. These are some common libraries used in Python in order to perform data visualization and data modeling. Okay, NumPy is when you are working with numerical data, you want to do some manipulation, then NumPy is used. Pandas is basically you can you can actually load your data set and perform other manipulations required for your data. Matplotlib and Seaborn are visualization tools given by Python in order to visualize them. And scikit-learn data scikit-learn package is where we can actually perform the machine learning. It contains the data set, it contains the models that we require, it contains the metrics that we require in order to evaluate. So these are the libraries we are going to use. If in case you don't have these libraries, it's just pip install numpy, okay, and then followed by it's like pip install pandas, then pip install mat matplotlib, and then scikit-learn as cborn and scikit-learn as well, okay, followed by that. Then if in case you don't have Jupyter Lab, you can open your terminal and just do pip install Jupyter-lab. No, Jupyter Lab. This is the command, okay. You can do this and install the required packages. Moving on, I will share you this code by the end of the session, okay. Don't worry. First step is loading the iris data from sklearn. Iris data is nothing but the data which consists of the flower features. For example, it contains the sepal length, sepal width, petal length of three different flowers. Okay, it's a type of flower. We are going to load it actually sklearn as the inbuilt data set present. So we are going to load this. I need to import, then I will load. Yes, I've loaded the data. Now I need to convert it to data frame for easier manipulation and accessing the data. Only then we will be able to access the data in an efficient manner. For that, I need to convert this data into data frame. Yes, converting. Now we'll just display the first few rows. Yes, head will display, df.ed will actually display the first 5 rows of the data set. So here you can see sepal length is present, sepal width, petal width, and target. Target. This is our output feature. It's gonna, since I said it has 3 flowers, it's gonna be either 0, 1, or 2. Okay. With these features, it is gonna categorize. It's gonna be 0, 1, or 2. Okay. Now we'll check. As I mentioned here in our presentation, data cleaning is important. Since this data is from scikit-learn, it does not have any null values. Let me run. Yes, it does not have any null values. Okay. As you can see, the this will actually give us how much null values are present in sepal width column. How much null values are present in this column? Since it is 0, it is showing me 0. Okay. Moving on. Now let's see how to, we will be displaying a bar chart distribution of target classes. Target class is nothing but the output. Okay, as I mentioned, there are 3 groups, 0, 1, and 2. We will try to do that. Run it. Yes, 0, 1, 2 are the target columns. Okay, these are group 1 flower, group 2 flower, group 3 flower. Okay, it has the count 0 number of target values has the count of 50. This has 50 value data in it, and this has 50. Totally we have 150 rows in our data set. Each category consists of 50. Moving on with, we'll now see how to display a line graph. I'm just giving the label. Line graph, as I mentioned, you can see with related to time or any other index of a particular data. Now let me run. Here I'm fixing the figure size. I'm plotting. I'm giving x as x. For x-axis I'm passing df dot index, that is 1 2 3 4 5, these index values. Okay, the row values, for example. Then moving on, df of sepal length centimeter. This is this column. Okay, this column which has the sepal length of each and every flower. There's going to be 150 records, so it's going to show that. And the label is, we are going giving a label as sepal length. And plot title, our title will be sepal length over index. And x label is that you can actually give a name for your x-axis, and you can give a name for your y-axis. It is index here, and it is sepal length here. Okay, for y-axis. Now we are going to plot. Yes, as you can see, a line graph is shown, which in which displays the sepal length over the different index number. Okay, moving on, we can display now a scatter plot. Scatter plot, we are going to do it for two variables. We can do scatter plot for two variables, saying that sepal length versus sepal width. Okay, x for x, for x-axis we are going to give sepal length, and for y-axis we are going to give sepal width. And hue is the target. These are for the visualization purposes. Like, I'll just show you once the visualization is shown. And title, x label is the name for x-axis, y label is the name for y-axis. I will run it and show. Yes, this is what we actually gave here. Okay, hue, the target, the name is present here. Palette, it's going to be deep for the color. And data, we are just passing our data frame, which we loaded the iris data and converted it to data frame. And then, as you can see, sepal length was a sepal width, the title, followed by the x label title and y label title. This is sepal length and this is sepal width. I have plotted this in scatter plot. This is how a scatter plot would look like. You can actually change its colors, you can change the way it looks like to a little different manner. All those options are of course available in Python. Moving on, now we can do the histogram. Histogram, okay. This is like we are going to see the distribution of our sepal length. You're going to see, one second, we're going to see the distribution of our sepal length. So we are giving the figure size. Histogram plot, we are going to give sepal length for the plotting. And then title as distribution of sepal length. X label, we are naming it as sepal length in centimeter. And Y label, frequency. That is like, I will explain. As you can see, sepal length for 4.5, the sepal length is 4.5, and how many times is it is present in our data is like around somewhere around 8 or 9. Okay, and when it comes to 5, it is like present around somewhere 23 or 22, like that. This is the frequency, how many times this particular value is present, and the histogram distribution will be able to show us. This is what the this is actually to see the distribution of a particular variable. And bar graph is to see um, bar graph is just for the categorical variable. For the categorical variable we can use bar graph. Okay, this is the common difference. Some people get confused to what is bar and what is histogram. This is the difference. It works of the distribution of the data, and it works for the categorical data, that is like data which can be grouped actually. Okay, moving on, we have heat map, correlation matrix. As I mentioned, correlation is when you are trying to figure out what is the relationship between two variables. Now, for example, a child is suffering from cold often, okay? Trying to figure it out, the doctor understands tries to understand mm, what are the habits that is being followed by the child. For example, if the child eats ice cream, it gets cold. That is one of the um, that is one of the that is going to be one of the features of the data. So we are trying to figure out whenever the child is eating ice cream, does the child is affected by any sort of cold or fever, anything like that. That is the aim, and we are trying to figure out the relationship. Okay, this is one of the example. Another example is that when in some cases, when one feature increases, the other may decrease. Okay, consider a feature of saying whether when wait consider a feature where when it rains, it is the people do not dry their clothes outside. So number of people dry their clothes in the terrace will be reduced. That is one of the example. It's like when one feature increase, another feature goes down. That is negative correlation. I'll plot it and explain it to you again. If you have any doubts, post it on the chat. Okay. Okay, as you can see, the chart is visible. Zero tells us neutral. They are not related at all. When one feature increases, the other do not get affected at all. That is what zero correlation tells. And when it is positive in number, when the correlation is positive, like as you can see, 0.96 is almost nearer to 1, right? The correlation matrix lies from 0 to 1. 0 means it's nothing, it's not like related at all. 1 means it's highly correlated. If one increases, the other also increases. And when it comes to negative, the length and sepal width, one variable increases while the other is decrease while the other decreases. One variable increases and the other decreases. This is what um, negative correlation is. Okay, the to find the relationship between the variables, we use correlation matrix. Moving on, we saw different types of visualization. Now we will move on and do some data modeling. Okay, machine learning modeling. X is that which will have only the input features, and Y is that will have only the output feature. We are going to take X and Y. Drop is nothing but deleting the output feature from the data and giving it to X, which will contain only the input features. Let me show you. X dot head of, okay, as you can see, this has sepal length, sepal width, petal length, petal width. Okay, now moving on, let me show you y dot head of. This will show you only the target variables. It's going to have, you can actually alter the number. Once you give head of 20, you can have 20 data. That is first 20 will be represented. Okay, first 50 columns, first 50 rows are having 0 target value, and next 50, I guess it's having 1, and followed by 2 for the next 50. So it's showing me 0. This is the Y has only the output feature, X has only the input feature, followed by, we are actually splitting the data here as well. For training and testing. Training data is nothing but you use it to train your machine learning model. You use that data and teach your model um, how the data will look like. Okay, that is what training data is. And just a second. Yes, that is what training data is. And testing data is nothing but um, when you when you use a set of data to test the system, how accurately it predicts my data. Once you train it, okay, you're just training. This is how apple looks like, this is how orange looks like. You're training the data, that's fine. After that, you need to test your system, right? To test your system, you definitely need some new data. So some unseen data is being used here. Okay, so xtrain, xtest, this contains the input features for training data. Input features for testing data is present in xtest. Y-train contains output features for training data, and y-test contains testing data for the output features. Okay, I'm giving the test size as zero point 0.2. This is 0.2 is like 20 percentage. 0.3 indicates 30 percentage. It's moving on. Okay, you can always give it in percentage for that, for splitting. 20% of my data will go for testing data, and other 80% will go for my training data. This is how most of the machine learning models are trained. You train the data with 80% and you test the model with 20% of data. Okay, moving on. I showed you these two, right? Now, let's initialize the logistic regression model. Logistic regression is a classification model. When I say classification model, I have not. Okay, let me tell you what is classification and regression models. Classification model is used when you are able to categorize your output feature. It depends on your output. Now, in our data, you are able to categorize, right? Our output will be either 0, 1, or 2. This is what the output will look like. When you don't know, for example, consider house price prediction. Okay, house price prediction is not like it is going to be 75 lakhs or 85 lakhs. It's going to be ranging from 30 to crores. Okay, it is having a large values. It is going to have continuous values, a large number of values. It cannot be categorized like this. Either it's going to be 0, it's going to be 1, or it's going to be 2. We cannot do that for some models. For example, house price prediction cannot be categorized. So when you are able to categorize, you use classification models. When you are not able to categorize, for example, house price prediction, you use regression models. Logistic regression has a word regression in it, but it is a classification model. Okay, try if you're curious why a classification model is named as regression in its name, try to figure out. Okay, it is, all these are interesting in AI. You can just google and check out why logistic regression is named as regression, but it is a classification model. If you have any doubts, post it, I will answer it in the last. Okay, and if you want me to repeat any part, you can ask me. Moving on to training the model. We are now training the model as we are going to pass the training data. X train is the input features, Y train is the output features. We're going to pass it. Fit is nothing but train. Okay, you're training the model. And now making prediction based on the test data. All your prediction is saved in your Y predict. Okay, now what you're going to do is, wait, let me show you. We will just view what is in Y predict. Yes, as you can see, it is predicted 0, 1, and 2 for each and every testing data that we passed. And now this is the machine learning predicted values. Okay, now we have the actual values that is present in Y test. We are going to pass that to accuracy score. what is y test? I'm sorry, we are going to pass a y test and y predict to our accuracy score in order to check how accurate our model has predicted. Yeah, it is 100% accuracy. I have converted into percent, but the accuracy score, let me show you. The accuracy score normally lies between 0 to 1. 0 indicates um, it does not predict properly at all. The score is 0, and 1 indicates it is 100% accurate. Okay, that is how it goes. Mostly, the accuracy value from 0.8 are considered to be good. 0.7 also considered to be good sometimes when for the complex problems. But bringing the accuracy 1 is really tough. Since this data is simple, it has only 150 rows in it, it gives me one accuracy for 100%. Yes, that's it for today's session. This was the quick overview and hands-on exercise for machine learning using IRIS dataset. I hope you found it informative. Then, if you have any questions, you can post it in the chat box. Wrapping up, networking is really important in IT domain. So you can connect with me on LinkedIn, subscribe to my YouTube channel if you want like tutorials related to AI, and then I post Medium articles as well as you can check them as well. And for the code which I presented now, I will show that I will post it in the chat box. Okay, I will post the chat box. I'll post it in chat box. Just a minute. If you have any questions, you can tell me. Otherwise, we can wrap up. I hope you people don't have any questions.
I think no one has the questions about this section. So let's come to
I will
the
post the GitHub
outcome.
link. You can get the code from there.
Okay, ma'am, thank you. Thank you, ma'am, for sharing your invaluable insights with us. To all of you who have joined us today, your participation evolved this thrilling journey of education and exploration of ML. Thank you, everyone, and thank you, ma'am.
Yeah, I have posted the
As we
GitHub
have
link
gained,
also. You can check out for the code which we have done right now.
as
Okay.
we have gained more
Yeah.
knowledge
Thank
from
you
our
so
resource
much.
person, it's time to test them with a short quiz. I will be posting the quiz link in a chat box, or else I will display the QR code. Please, everyone, join us. Kindly, everyone, take a time to join us. It's just an five 5 minutes quiz. I will start the quiz now. Join with the QR code. Please scan the QR code and join us, or else use the game pin to join us. We have only 10 questions for the quiz. Please take a time to check your listening section. Sorry for the interruption. Please scan the QR code, or else use the game pin 2665609 to join the quiz. I can kindly request all to join the quiz. Please join the Zoom.
Then only can able to
Please join the quiz to get your certificate for this section. It's a very simple quiz. Please join us. The quiz section starts now. Please answer the question first to get the certificates. Be the first to be the star of this quiz. Please join the quiz with a game pin. So I hope all you have attended the quiz. So thank you everyone for participating in the quiz. Now I request all the participants kindly fill the feedback form. Feedback form will be posted in the comment section. Please fill the feedback form to get your certificates. Thank you all. We hope you have enjoyed our section. Thank you everyone.